today we're going to talk about the Java synchronization and deadlocks. All right. So what is Java synchronization? Right. So basically, it's a way for you to get a mutually exclusive lock on a resource. And the way that you do the synchronization is by using the synchronize keyword. Right. So then in Java, normally you would say synchronize, right, followed by, right, so you would do synchronize, right, followed by this object, right. So this basically is the object that you're gonna lock, right, and then from there, you do whatever um, code that you put in between this block, and that piece of code is considered atomic. Atomic meaning that from another thread's perspective, that operation is considered as one unit and cannot be broken into into more finer units of execution. Right. So in Java, you can besides synchronizing um, the object, you can also add the synchronize keyword to a method, right? So in this case, if I add it to a regular method, it's called the instance method. This the synchronize right here, right? It's going to be the same as It's going to be the same as the synchronize right here, right? Without adding the synchronize here, right? So basically, what the adding the synchronize here, the synchronize keyword to the method signature, is basically synchronizing on um, a object which is the class itself, right? So this right here, right? So these two methods are the same, right? Right. So again, we can do the same thing on a static method, right? But if you synchronize on a static method, you are actually locking the class itself, right? In this case, my class name is going to be hello world, so that's why it's gonna lock the hello world that class, right? So implicitly, this is what this guy is doing right here, right? It's basically locking this class right here, right? Right. So that's what the synchronize with the when you synchronize a static method, that's what it will do. Right. So let's talk about deadlocks then, right? Because the reason why we're having this discussion is to talk about deadlocks and how synchronize can lead to deadlocks, right? So in order for us to discuss deadlocks, we have to understand what a deadlock is, right? So in this case, when we talk about deadlocks, right, it has to involve at least two threads, right? So here, there has to be at least two threads, right? So if you have one thread, you cannot have a deadlock with just one thread, right? So deadlocks only happen in a multi-threaded system, right? And those threads are pretty much blocked, right? Block meaning that they cannot, they're waiting for something, right? And normally they're waiting for um, to gain access to a lock of an object, right? So therefore, once it's blocked, it cannot continue. So therefore, it cannot successfully complete its mission, right? Whatever it's supposed to do, it cannot complete, right? Due to the fact that um, the thread is because because each thread holds an exclusive lock to a resource required by the other thread, right? So therefore, each one has a dependency on the other one, and since each one is waiting for the other one to release the lock to its resource, to the shared resource, and since that will not happen, that's why we call this a deadlock, right? Because basically those two threads will wait forever and it will never complete. Right. So here, let me demonstrate how to create a deadlock. All right, so let me go into my Eclipse. All right, so here, right, I created a very simple program that would basically go into a deadlock. Right, so what I have is I have a main. Right, so I have this main that calls this do task one, and this do task one has a synchronize in its method right here, right? Right, so this synchronize is basically acting as a lock. So basically, it's going to lock basically the deadlock one class, right? So this, and then this do task one, it calls do task two, right? And again, this do task two also has a synchronize, right? So then since this synchronize is part of the static method, that means they're both locking the same object, which is the class deadlock one. Okay, so but again, in order to have a deadlock, it must involve more than one thread. So the other thread is going to be here, this one, this swing utilities, right? So what this swing utilities does is basically it will basically add a runnable to the swing thread, and the swing thread itself is a thread that would that pretty much handles the GUI repainting and updating, right? So in this case, we didn't really do any GUI modifications, but instead we asked that this swing thread call this do task 2, right? Which again, when we call this, it will basically try to get a lock from the class. And if we, well, let me show you what happens when I run it. Right, so the printout here, it says right here in do task 1, right, and then it says then calling do task 2, and that's it. It never finish, right? So to show you that it's deadlock, right, if I were to remove this synchronize here, right, it basically does what we want it to do, right? So it basically goes into do task 1 and then goes to do task 2 and then comes out and then it finish, right? So what happened, right? All right, so if we look at the debugger, right? Okay, so here this program is stuck, right? So now if I pause my JVM, we can see what is happening. Alright, so here I have my debugger. So now if I pause the JVM, right, you can see that there is a this is going to be the swing thread, the event queue thread, right? And here it's going to call do task 2, right? It's calling here, but it's waiting for a lock, right? And in the main thread, right, it's calling this swing invoke here, right? And it has a lock. It owns this lock right here, right? Which is weighted by this event dispatch thread, right? So in this case, this is going to be, so basically this is basically where each thread is at its current execution state, right? So the main thread owns a lock and is basically waiting for by this event queue, right? And then the event queue thread is also waiting for a this lock, right? And in both cases, it cannot proceed, right? So, and the reason being that is because in this do task one, we basically ask that this swing utility um, to call, or basically we call this invoke and wait method. Basically, we're asking for the swing thread to execute something and wait for that return, right? So basically, in this case, this is blocking um, and waiting for that thread to succeed, but it would never succeed because it can't get the lock, right? And that's how we get into a deadlock. Now, one way that we can solve this is to not have the swing utilities wait, right? So we can do invoke later, and this basically will execute this piece of code asynchronously, right? This piece of code right here asynchronously, so therefore it doesn't have to block, right? And if I do that, right, it does finish, right? But you can see that it doesn't do it in the order that I wanted to do it, right? I was gonna, so in this case, you know, the task one finish and then task two finish, right? The reason being that, you know, task two cannot really do anything until the lock is obtained, right? And that's can only be done after task one has been completed, right? So that's basically the sequence, right? So let's see. Okay, so what can you do to avoid deadlocks, right? So when you use synchronize, right, you avoid synchronizing on the method itself, because the method can potentially have a lot of code in it, right? So when you do use synchronize, try to limit it to a small block of code that is necessary, right? Right. So in this case, a very popular example is when you need to synchronize some data structure um, that is not synchronized in itself, right? Because there are data structures that are synchronized, but if you use a like a hash table or a hash map, those are not synchronized. So you have to synchronize that data structure in order for you to access it, especially in a multi-threaded environment, right? So when you do synchronize those data structures, right, only synchronize the operations on that data structure. So in this case, if I have a map, right, I should only synchronize the part that gets the value from the map, or that, you know, updates the value in the map, right? And then that's, you know, doing that basically will keep your code very small, and the potential for deadlocks will be dramatically reduced, right? Also, you want to avoid calling functions in your synchronized block, right? Right, because when you do call those functions, you are holding a lock, and those functions can be either your functions or it could be some other people's functions. You know, basically those are callbacks, right? So if you cannot guarantee that those functions will not lock something, then you shouldn't call it, right? Because again, those, you don't know what other people is going to do with their functions, and those functions can come back and lock the same resource that you already have a lock on, and if they do that, that means you can potentially create a deadlock, right? Just like the Java example that I shown before. Right? So next, the another way to avoid deadlocks is basically not to use a synchronized keyword, right? And there are certain patterns that you can replace the synchronized keyword with by just using the atomic classes from Java util concurrent, right? So here, right? So here you have this in this package, you have data structures such as atomic boolean, right? You have atomic integer, and you have atomic long. What these provide is a data structure where all the updates, delete, and read operations are atomic, right? So you don't have to worry about synchronizing them, synchronizing access to that data, right? Now, also, um, Java Util Concurrent library also has a package called Java Util Concurrent Locks, right? And then what this provides you is it provides you a replacement for the synchronize keyword by providing you data structures for locking also. So here it provides you also a lock mechanism, right? And this is going to be a replacement for synchronize, and this lock is basically going to be a mutually exclusive lock, right? They are, besides the mutually exclusive lock, you can also have a read-write lock, right? So this read-write lock allow you to have a finer control over how things are locked, right? Because you can have a read lock, right, which is a share lock, right? So share lock means multiple threads can get the lock, right? And this is mainly for reading data, right? That just means that in a read lock, you're not going to modify the data, right? So that's why multiple threads can gain access to it. But however, if you're going to modify the data, that means you would want to create you would want to get a write lock to it, right? So this write lock will get well basically the write lock is going to be an exclusive lock. So that means that only one thread can have a write lock, but multiple threads can have a read lock. Right? Okay, so let's talk about how to use the Java util concurrent locks, right? So let's say I don't want to use this synchronized keyword, right? And I want to use the locks instead, right? So what I can do is I can do the same. Okay, I can do this. So if I have okay, so instead of using synchronize, I can use a lock, right? And this lock is an interface, right? So therefore, I have to declare some implementation, and the only implementation available for this one is a reentrant lock. And reentrant meaning that you can lock again. The same thread can obtain the lock again. So in a way it's recursive, right? But again, for every lock you have to do an unlock, right? So in this case, since here what I can do is I can say lock, and then the and then you should always have a try finally, right? And in that finally you have lock and unlock, right? And again, it's going to be the same here. Since I synchronize on a static method, I am actually locking the same resource, which is going to be the lock, using the same lock. Okay, so now if I run it again, it's going to be it should do the deadlock, right? Again, it basically goes into a deadlock, right? So then let's say that if I want to avoid that deadlock, one thing that potentially you could do is to have two locks, right? So you can say lock 1 and lock 2, right? So then you have more granular lock, right? So in this case, I want to do lock 2 and lock 2, right? And in this case, it basically does what I wanted to do, right? Now, what if I cannot have two locks, but I but what if I wanted to know if there is a deadlock, right? So one thing that you can do is you can again use this try lock, and this try lock has a timeout, right? So we talked about timeout before, right? So timeout is really a good way for you to protect yourself against this situation, right? In this case, it's a deadlock, right? Deadlock situation. So if I were to say I'm going to try to get this lock in 5 seconds, alright, so in this case, I would have to do this, right? So if success, right? Else, I can print out something that says okay, so let's see what happens. Right, so there you go. Right, so in this case, the try lock waited 5 seconds and they couldn't get the lock, right? Because that lock was already locked in another thread by the first task. And then from there, the try lock fail returns unsuccessful, and then that is why, again, we can print out this message saying there's possible deadlock, right? So this is kind of a way of detecting deadlocks, right? And if we were to do invoke later, right, in this case we avoid the deadlock, right? So therefore, again, this try lock should succeed immediately, and then from there, you should not have any deadlocks.